TX 1600. All right, here we go. Today we are going to talk about basic hand tools. So let's get going. All right. Okay. So this is a hammer. So is this. This is what's known as a claw hammer. Because it has this claw on it. This hammer is primarily for working on your house. It's for pulling out nails. It has these two barbs, I guess you could say, and it's arranged in a way that gives you leverage to pry. Okay, and of course the face of the hammer here. This really is not for the shop. This is for working on your house, pulling out nails, hammering nails, prying 2x4s apart, that kind of stuff. And I am going to show you the proper way to actually use a hammer. But for right now, what we're going to do is talk about hammers that belong in the machine shop. This hammer is what's known as a ball peen hammer. Ball peen hammer. So it's interesting. It has a flat side. Some of them are flat and they have a slight dome to them, and then the other side, it's round. The reason this is the peening side, and let's discuss what peening is all about. So, what we're going to do here is we are going to put two pieces of metal together and secure them with a pin. All right? So what happens is, let's say we've got a piece of metal, cutaway view, like normal here, and we slide in another piece of metal right here. Okay? And there's two ways to go about doing this, actually. We're going to start off real basic here. What we can actually do is, if the clearance is close enough, we're not going to talk about fits yet. We're going to talk about fits in a couple weeks. If it slides in like a sliding fit, like it slides in easily, or even if you have to tap it in, what we can do is we can take the round end of this hammer and I don't want to say hit it. We'll hit it, but we're not going to, we're gonna tap on it, and we're gonna do it a lot of times. Say 10 times or 15 times, well, however much it takes, with the ball end. That's why it's called a ball end here. And what we're going to be doing is peening. And as this hammer strikes down on the top of this, what's going to happen is this metal is going to expand in this hole. Okay? And by expanding, it's not going to come out. Like, you're going to have to press it out with like a hydraulic press. Very simply, that's what peening is. You can do that with a rivet. So let's say you had two pieces of thin metal. Let's draw that really quick here. Let's say you had two pieces of thin metal, and you drilled a couple holes in it here. So you drilled a few holes in it. Actually, erase that. I'm going to get one of my new fancy pens here. They're bigger and better. Oh, look at that, man. That's awesome. All right, so let's say we had two pieces of metal here. And we drill a hole in it, and we want to fasten these together, and this could be like, well, other way to do it is there's our holes, our two pieces of metal. What we can do, I'll get used to these pens very quickly. All right, is we could put another piece of metal in here, say what's called a rivet, and it might have a head on it, like this. And what we can do is start peening. And believe it or not, it's going to expand this rivet, okay? And it'll hold these two pieces of metal together. Oftentimes we'll use a punch. I don't have a punch in front of me, but that's okay. We're talking about basic hand tools right now. The other thing I want to talk about is, and I'll show you a couple more hammers here, is how to hold a hammer. A lot of times I see students doing this. See, they choked up on the handle. No, the handle's there so you get leverage and more force on impact. And I'm going to talk about force and impact. We're not going to go into the math of force and impact, but I'm going to try and explain force and impact. You need to hold the handle by the handle, okay? And it's hard to do at first. Believe it or not, using a hammer the right way takes a lot of practice, maybe even years. It actually does. I know. You're like, oh, come on, dude, it's just a hammer. It does. Very rarely do you use a hammer like this. You would use it if you don't want to apply any kind of force or impact. So it's just going to be you're like, just very gently, like you want to just knock something apart really little bit that you can't get apart with your hands, okay? But that's very rare. So you really want to practice. You got to practice. You want to hold the hammer by the handle. So there's a few other types of hammers. They're really not hammers. But this here, this is a mallet. And what it has on here is I don't want to say hard plastic, but it's not soft. But it's not that hard either. Like I can almost scratch it with my fingernail. And this is a mallet. So what might you use a mallet for? You're going to use a mallet to separate parts that you don't want to damage, because the hammer, because it's metal, it's actually hardened. A ball peen hammer compared to a claw hammer, all right, they're tempered. The claw hammer is hard metal, okay, but the ball peen hammer is hard metal, and it typically is a carbon steel that's been hardened and tempered. They're for the machine shop. They're not for working on your house, okay? So when you hit something, piece of metal with this, you're going to dent it. This is a little more gentle. So when you tap things into place, things like that, you want to disassemble something, you're going to use a mallet. And I just happened to grab this, and mallets come in all shapes and sizes. Soft, hard, dead blow. A dead blow hammer is basically a mallet that's hollow, and inside is filled with lead shot. So when you hit it, it doesn't bounce. So when you hit something, it goes dong, right, dong, and it bounces. Well, dead blow hammer, what happens is as you throw down, all that lead shot, right, is in the back, right? It's moving back, and then when it hits, the lead shot goes forward inside the hammer, and it doesn't bounce on you. Okay, that's called a dead blow. This is pretty cool. This is I guess you could call this a mallet. I don't even know what to really call this. I would call it a mallet, but the head is copper. This serves actually two really incredible purposes. Okay, it's copper. I think this thing weighs probably over 10 pounds. Okay, it's solid copper in steel, steel casing here with a wooden handle. Okay, no, I'm not going to show you how to attach a handle to a hammer head in this class, but there is a technique for that. Of course, there's a technique for everything. So this kind of serves two purposes. It's really cool. It's copper, so it's soft. It's much softer than, much softer than this hardened steel ball peen hammer, and it also weighs a lot. So when you hit something, it protects what you're hitting, and the amount of force and impact that goes in is much more than just your regular hammer. Yeah, there you go. And it also has a little, it still bounces, but it has a little bit of that dead blow effect. All right, so there's some hammers. You'll see me tap stuff in, and I will show you how to use a hammer the right way. All right. Next on our list, hammers. Yep. Guess what? We are going to talk about screwdrivers. I know. Like, what? Okay. This is a flathead screwdriver. Actually, it's not. It is, and that's what they're called nowadays. But really, this is actually just a screwdriver. It was invented a very, very, very long time ago, maybe the 1600s, 1500s. And believe it or not, it had a hard time being accepted in the world, and it didn't really take off for a couple hundred years after that. The problem with these, even though they're still widely used, is that they don't self-center well. So if this is your screw head, this is why they're difficult to use, right? So that's your screw head. It's very difficult to get this to line up right in the middle of your screw head. It's always kind of off to the side or like hanging out to the side, which leads to an ununiform twisting motion. Okay, and then of course if the head doesn't fit snugly in the slot, it's going to cam out on you. So we'll talk about what camming out is more specifically in a moment. Believe it or not, this tapered part right here, that's called the keystone. Okay, that's pretty self-explanatory. They're available in all different lengths and sizes. In a moment, I'm going to show you all kinds of stuff. Okay, the most popular screwdriver, I think, in the world, not for manufacturing, is what's known as the Phillips drive screwdriver. And it's named after a gentleman. I believe he lived in Portland, Oregon, and this was invented in the early 30s and patented later in the late 1930s. And then, just coincidence, but Phillips, the company, bought the patent, and yeah, that's the history of Phillips. But we need to look at that, and this is important. Okay, so if this is our screw head, a Phillips screwdriver, I'm going to try and do this right. Looks like this. Okay, you've all seen it. As a matter of fact, I believe the most popular screwdriver in the entire world is the #2 Phillips screwdriver, and I bet that almost every single one of you have one at home. Okay? A #2 screwdriver, Phillips screwdriver, looks like this. Let's see, do I have a? Looks like this. No, it's not the best screwdriver in the world. That's what I found. This is a #4. Phillips screwdrivers range by number from number 3 zeros to number 4. Okay? The problem with Phillips screwdrivers, if we spin, let's say we're going to unscrew it, is we're going this direction, counterclockwise, is that this area in here cams out. It rounds over. It also known as, we call it, stripping. Okay, the technical term for that is camming out. So it rolls over and then no longer grips properly. So the screwdriver tip rolls this edge over and it strips or cams out. So it rolls it over and then you get yourself into some trouble. You really need to use the proper size screwdriver for the size fastener. Here's a number 4, a number 3, a number 2, the most popular. This is a number 1. All right. Okay. I got some other ones here too that I want to show you. Let's see. This looks like a 0. See, that's pretty small. And I have this little kit here that I brought. Okay. This one right here, this is a 00. It says on the handle. Okay. These are known as jeweler's screwdrivers. These are your knockoff. They have this little plastic thing here, but I brought this so you could see it. Right? This is an actual jeweler's screwdriver, and this is a standard jeweler screwdriver, so it's not a Phillips drive, it's a flathead. And this part right here spins. And the idea is that you can put this into your palm, see that? And this spins. So as I apply, see it now, right? As I apply a little bit of pressure, that's the idea. This is called a jeweler screwdriver. Okay. Now, let's move on to the next most popular type of screwdriver. And I would say, and this is not by any means very accurate, but I would say that this has become popular for home use probably in the past 10 years. So 10 years ago, this existed I think this was invented in the mid-century of 1900s, around there. I don't remember the exact date. But what I'm going to show you is what is commonly known as a Torx. Okay? And a Torx screwdriver, or drive, like I was saying, it's mid-1900s, is a 6-point star. So if we draw a star, drawing it, so you'll get the idea. That's not bad. And this became very popular in manufacturing. The reason that it did is because that Phillips drive and the flathead drive, well, the flathead drive, obviously, when it's not centered, it's gonna roll out or cam out or strip on you. And then the same with the Phillips drive. Now the engagement on the Phillips, or on the Torx drive, Torx is spelled like this. Torx. On the Torx drive, really engages along these surfaces here. Along these surfaces, we're undoing again this direction. Along these surfaces here, so it not only engages really well and is really accurate, so for like robotic arms and things like that, but it also is great for your home. So like construction, things like that, electronics. The sizes for Torx go from T1 to T100, okay? Let's see, I think this is the one that I showed you. This is a T25, I believe. It might even say on here. T30, that was a T30, and this is a T25. You can even see it's not that much. You can just, whoops, there we go. T25, T30. So the bigger the number, the bigger the drive. For those of you who worked on cars, especially like vintage cars in the 70s, you might notice that all of a sudden, out of nowhere, they started to put your seatbelt on the car with a Torx drive screw. When everything else in the car was your regular fastener. It was a Phillips drive or a bolt. Well, because Torx drives were really only for manufacturing back then, after they became commonplace in industry and manufacturing. And so the idea was, oh, they won't take their seatbelts out, right? Because in the 70s, people were still like, I'm not wearing my seatbelt. So that's sort of a brief little introduction, kind of folklore, if you will, about what's going on there. Let's see, is there anything else I can say about... Oh, if you got the choice at Home Depot to buy a Phillips drive or a Torx drive, go the Torx drive. Nowadays, they come with a little bit you can put in your portable driver, your cordless drill, which we're going to talk about soon. They come in the box, so you know what? Use the Torx drive if you can above the Phillips. But the Phillips number 2 is by far the most popular drill or screwdriver and fastener, I think, in the world. I lost my pen. Here it is. The next one. The next most popular type and most successful. There are many types of screwdrivers, bit, the bit part, the drive part, and fasteners out there. But we're just going to talk about the main one. The next one is what's commonly known. Oh, I forgot. It's a Torx. A Torx drive is what we call it, like at Home Depot, and just like street slang. It's actually the technical term. Hexalobular. I know. That's the hexalobular is the technical term for a Torx drive. All right, next. The next most popular type is the square drive. Square, Blake. Square drive. And it was originally known and commonly known as a Robertson. All right. The screw head profile is going to look like this, and it's a square drive. Okay. They're very popular in Canada. I know. They're now, I think we started to see these more at like Home Depot in the same time frame, roughly 10 years ago. That's very rough, you guys, okay? But here is a square or a Robertson drive, okay? And the cool thing about these guys is not only do they engage really well, like the Torx, okay, but their keystone is a keystone. So that profile is actually angled. And so what that does is if this were to fit perfectly in here, it'd be hard to get it in every time. Like it'd be like you gotta like wiggle it to get it in. This allows for this to just shook because it's tapered, right? And engage, and then it's really engaged along this profile here. Okay, so these are great. They're great for woodworking. Fantastic for woodworking, actually. I prefer these for woodworking for fine cabinetry. fine woodworking over the Torx, actually. These are fantastic. Yeah, I still use Phillips all the time. But for stuff that I make, kitchen cabinets, things like that, I'm going to use the square drive or the Torx drive. And like stuff that I work on my house with, if I need to put up something new, I'll use the Torx or the square drive, just so you guys know. Okay, the next most popular one, and the last one we're going to talk about, is the famous Allen key. And all right, it's actually a hex drive. That's its technical term. Hex drive. And it's commonly known now as the Allen key or Allen wrench. Heard that lots, okay? The reason why they call it the Allen wrench is because the Allen Manufacturing Company bought the patent for that, okay? For that type of hex drive. But it's a hex drive. It, just forgot here. It has like a bolt pattern, actually. That's not very good drawing. Like that, okay? And the sizes for this are standard and metric. In standard, they are pretty much, when they get small, I don't remember right off the top of my head. When they get really, really tiny, they're like in the 50,000s and things like that. But they are typically in 64ths. Whoops. 64ths. And when they get up to a quarter, so when we get up to a quarter, they start going into 16ths increments, okay? So the smaller ones are the really small ones I'm not going to worry about. But the small ones, they go in 64th increments, and then after they reach a quarter, they start to go in 16ths. They also are available in millimeters, and it's the same thing. When they get really small in millimeters, I don't remember what the decimals are, but they are typically done in half millimeter segments until they get up to a certain point, and then they go into 1 millimeter increments, okay? So that's a little bit on screwdrivers. We're going to have a fastener lecture, and I'll talk more about fasteners in detail and their head profiles and what to choose, right? Like, what fastener do I buy for what application? But right now we're just talking about the actual driver. Okay. Oh, another Allen wrench that has a T handle. This happens to be a 1/4 inch. So that means that the hex drive here, that's a 1/4 inch. Got a couple here. Here's an 1/8. Okay. All right. T handle. Okay. All right. Next. This is actually a real important one. I want to talk about files briefly, and I'll demonstrate how to use one, but I want to talk about files. I have quite a selection here in front of me, and here's one without the handle. Here's the handle. So before we start talking about the technical parts of the file, I want to really emphasize that you really need to use a handle, and there's lots of reasons, but there's two really primarily important reasons. The first reason is that the handle gives you the control that you need to. This is how I hold it. That's how I hold it. Not all the time, but most of the time I hold a file like this. Gives you the control you need to use it effectively. The other reason is that this tang you see when you're holding a file, it can get you. See that? It can really get you in the wrist or something. It's not safe. So I know. Most of you who have a file at home don't have a handle. Some of you do. or the handle's falling off and things like that, and you end up taking it off. I'm not going to bark at that home use, but here at the university, it's required that you use a handle, okay? And for two reasons that I gave you. Number one is safety, and number two is because it's going to be more effective. It's simple. This just goes on. It's got a little insert in here that's threaded. Not all of them do. This one does. These are the good ones. And you go in here until it stops. Won't come off. Okay. So let's look at files, a couple of their profiles, and talk about some of the technical aspects of a file. Now, first of all, there's a couple things we need to know. Let's look at a file here like this first, and then I'll erase this because this is actually pretty simple. All right. This part of the file down here, this is called the tang. Okay. And this is where, that's where the teeth are. Okay. Notice I didn't give this a label. The nomenclature on files is not set in stone. It really isn't. There are a couple things that I'll show you that are, files have been around since the Middle Ages. Okay? So the nomenclature on them is not totally set in stone. I call all profiles of files, this is a round one, I'll show you some more. This is a flat one. Their teeth are all, they're not the same, but they all have the same profile. This one is less aggressive than this one, but the profile is still the same, even though this is round. Now, this is just me, okay? I call all of these files mill files. They're all mill files, okay? But their profiles and their cutting teeth are what separate them, okay? So I can erase this now. So this part of a file, no matter, my way of saying it is that they're all mill files. Mill files, okay? Where it gets interesting is if you look on the tang of your file, you're going to see a label. And then if you flip it over, there is either going to be nothing, okay? Or it's going to say, on this particular one, and depending on the brand, it's different. I know, there's no set thing. This says, hand second cut, okay? Well, if we look to see the different profiles of files, let's see, what's this one say? This one says, bastard. What? All right. So typically it's rough, medium, bastard. I have no idea where this came from. Second cut. Remember this right? It's been a while since I've talked about this one. And then smooth. And there's one more, but it's very uncommon. The really, really fine one. Okay, it's really uncommon. This is what you're gonna see. Okay, this is what you're gonna see. Smooth. A rough I gotta tell you, in file world is really, really rough. I don't even think you can buy one of these at Home Depot, okay? You will see often on the tang of a file, bastard, that's what it says. That, I'm gonna say, is the medium file, just from experience, okay? And then you don't see that second cut very often like I just showed you, but you will see smooth, okay? And you are supposed to use them in the consecutive orders as we go, okay? I think that's pretty obvious about what's going on there, but let's look at the teeth. Let's look at the teeth profile. If we look at the teeth profile of a file, it's going to look like that. Okay? I take a file, and they cut on the push stroke. Okay? They cut on the push. Most of the time, you're going to see people filing like this. And as a matter of fact, I've even heard, I think I've even read it, I've heard expert machinists say the pull is the cleaning stroke. All right, that's false. Totally false. I want you to think for a moment, and we're going to really analyze this when we get into saws, okay? I want you to think for a moment about if we make a cut, and I push, and I put some of my body weight into it, so I've got 50 pounds of push in, and then say 75, 100 pounds of body weight going into it, you know, or 100, 150 pounds, and these little tiny teeth. When I pull back, okay, what do you think might happen? What's going to happen is these teeth are going to bend up like this, all right? And if they're doing that, now we just have a round surface here, okay? And we're not going to be able to cut anything. So it's really important to, when you're filing, is you don't want to exert pressure on the pull stroke. If any at all, you could just lift up and pull in air. And then file, okay? You don't want to do this. That you're going to ruin your file. All right, how to clean a file. It's definitely, I told you, it's not the pull stroke. So they make this instrument called, our tool called a file. This is called a file card. And on one side is a wire brush, and on the other side is this natural hair brush. And it's real simple. The wire brush, the wires in the brush get inside this tooth here, okay? And they knock out all the chips or dust. That's how you do it. You knock out that with the metal side, and then with the brush you just come back and you clean it off. That's how you clean a file, okay? It's called a file card. File card. That's how you clean a file. Files, because they need to cut metal, they're hardened. As a matter of fact, they're case hardened. We'll talk about that weeks away, about what hardening is. So what's important to understand is that they don't bend. So like, you know, metal bends, okay? These don't bend because they're so hard. They break. Just so you know. Okay? And I think that, oh yeah, one last thing about files. I'm going to show you the 5 most common, files come in all shapes and sizes. I'm going to show you the 5 most common profiles of files, what they're called, and a couple tricks. So we've got what's commonly known as a flat file. We've got a round file. when they're tapered, a round file is tapered like this. See how it's tapered? People call them rat tails, and I think that that is technical, but that's open for debate. I'm going to debate that with the manufacturing experts. I sure will. I'm going to debate that. But if you look it up, you're going to see rat tail. I'm going to debate that. This is a half round. This is a square, obviously, and the other most common type is a triangle. Okay? Why did I spend the time to draw this stuff? Because it's really important that you know on the sides of these files and in the corners. And in the corners, on all of them. Alright, are teeth. Which means that if you wanted to file, you got a part that looks like this, and you wanted to file down this plane, and there's teeth on the side of the file, you're going to end up, if you want to get in that corner, you're going to end up doing something like that, all right? And that would be bad. I grabbed this particular file. Now this you can't get at Home Depot, but they're very common, but I don't think they sell them at Home Depot. This particular file, if you look closely there, is actually smooth on one side, and then if you flip it over, it has teeth on the other. This is cool. Quick tip of the day. When I buy a triangle file, like even at home or at work, I always grind. Notice I said grind. One of the corners round. Okay? Just one. And if I need to, I can hit the other ones too. I'll do that on a square file. I'll ground one of the corners round. And on a flat file, I will grind one side, not all the time, but sometimes I will grind one side smooth. Why do I say grind? Because remember I mentioned that it's case hardened, okay? Because it's case hardened, you can't cut it. You really can't sand it. I mean, you can. You're going to end up going through like 5 packs of sandpaper and a whole day's worth of time. So you can, but I wouldn't do it. So you have to, because they're so hard, you can't cut them. You have to grind them, okay? Yeah, technical difficulties, I know. Okay. Wrenches. Wow. Simple. Wrenches. This is what's known as a combination wrench. Obviously, the reason why it's known as a combination wrench is there's 2 different wrench styles. This is an open-end wrench, and this is the box end. Now, I'm going to show you why, but we're going to want to try and always use this box end wrench as opposed to the open end wrench. So when you look at a bolt pad on here, look at a bolt. Whoops. Bolt head. When you put the open end wrench on a bolt head, it needs to slip on, which means if you've used one, it kind of jiggles around. What's really happening there is as that wrench comes up, we're gonna loosen the bolt. Actually, it's doing something like this. Imagine, right? So the only area that it's making contact actually is here and here. And like on the Phillips screwdriver, the Phillips fastener, we talked about camming out. That's exactly what's going to happen. If the bolt has been fastened too tight, or if it's rusty or it's stuck or whatever, and you try and use that open end wrench, you're going to end up rounding out this corner, and then you like think to yourself, oh, I'll go to the next one. Well, you know, you're just going to end up rounding that corner out. Okay, and next thing you know, you got a round bolt, and you're stuck. So, whenever possible, you really want to use the box end. And let me show you why. All right. So that box end, you can see this is a 12-point star. It's going to actually grab all 6 corners in this area here. I don't need to go all the way around. All right. It's going to grab all the way, and you're going to have more surface area and more contact to loosen your bolt. Show you a couple other wrenches here. So then why do we have this, right? Well, often there might be a bolt that you can't get access to with a box end wrench, like there might be something in the way, right? You couldn't slip it over, so you need to slip this in there. That would be one. Another very common application is, say this socket here, which we'll talk about in a sec, is got a pipe or a tube going to it, right? And obviously the box end wrench won't go to the bolt, right? So you would need to slip this on. They make which is called a flare wrench. It's a box end wrench, and if you look closely, you can see that it's been cut, and there's still 2 corners, so it's only really missing 1 corner. Typically, these are for automotive use, although for brake lines, anything with like a hydraulic, so tractors, all that, right? But they do come in handy because there's lots of research equipment. Swage lock fittings, even though, yeah, that's another topic. Okay, next. This is a ratchet. And this happens to be a 1/2-inch drive ratchet because the key here is a 1/2-inch square. And what a ratchet is, and this is the socket, it'll tighten, and then, okay, and then there's a little lever here. Flip it, and now it'll go the other way, okay? So that's pretty simple, but there's 2 types of sockets, and you're going to see one is a 6-point, this one, and this one is a 12-point. So just like with the open end and the box end combination wrench, you really want to try and use the 6-point. The reason for that is very similar to, not the same, but similar to the what we had going on here. Let me explain that really quick with the bolt. So that 6-point socket is going to grab the bolt. We're going to loosen more along this, not all the way, but like that. Okay? And the 12-point socket is going to grab the bolt there. So there's a lot more surface area with the 6-point socket than the 12-point socket. So why would we even have a 12-point socket? Well, I'll show you. In a lot of applications, not just automotive, but a lot of applications, we are in a confined space. So let's put up some barriers. I'm not even going to call them walls, they're just barriers. So this is solid something, and there's a bolt in here, right? Well, this 6-point socket needs to align to that. And so if you had the ratchet, it might end up like this, right? So it's like you can't, that's the only place it aligns. With the 12-point, you double your chances of alignment. So you might be like right here. And now you can, this way, now you can, within your constraints, okay? That would be the use for a 12-point socket. The most common ratchet sizes are 1/2 inch and 3/8. Okay, and this right here, this is what's known as an extension. Okay, so you might want to use it if you need to reach down in somewhere where you can't, right? This won't fit. So if you could imagine these walls coming out, like you could put this in, right? And now you could turn this all the way around. You wouldn't have to, you wouldn't, I think you get it. Okay, so that's a ratchet and wrenches. Very simple hand tools and the flare wrench. Let's move on. All right, what I've got here is your famous portable or cordless portable hand drill, okay? Most of you probably know this, but there might be some that don't. This is the battery. It's rechargeable lithium battery. Slides in here, and this is the trigger. There's a lever here. Okay. This makes it go forward. That's reverse. Move it over. That's forward. Go over. That's reverse. Okay. Up top here, most of them have this switch, 1 or 2. So it actually does 2 things. One is slower. Okay. One is much slower and applies a bit more torque, actually. At 2, if you put it in 2, it's a lot faster with less torque, okay? Now, on this area here are 2 very important things. This device, which holds the drill bit, and then you tighten up, this is called a chuck. A chuck is on the drill press. It can be in the vertical mill. Obviously the portable hand drill. Okay, this with the 3 teeth that grab the. You saw that when I showed you the drill press. This is a chuck. Okay, so that's where the drill bit goes. I don't like to bottom out my drill bits. There we go. Okay. And right after the chuck, this thing that turns here, see that? This turns. And there's an arrow right here. This is a clutch. All right. And it has a few different symbols on it. Right here, can't really tell. I don't think you can see it. But there's a drill bit, okay? That means drill. So 2, fast, right? If I had a small drill bit in it, drill. If I move it down, it'll say it starts at 21, and I move it down. What it's actually going to do is limit that clutch. I have it on 1 so I can hold it. Okay? So if I had a really narrow fastener or screw, and I screwed it into a piece of wood or a piece of metal, and it was really small, if I had it on 21, when the head hits the material, it's just going to break. Okay, so you can clutch down. So that's really important. Not all drills are the same. Notice that if I put it on high, I can't hold it anymore. Okay, I can't. Okay, it's impossible. But I can on 1. So it's good to get to know your drill. If you buy one and it's brand new, try it a few times, and on some scrap wood and some old fasteners that you're not going to use. The other thing I want to point out, it's a little tricky, is this trigger that you pull. It's a variable speed trigger. So when we were talking about drill bits on the first day, or second day, and I mentioned repairing the fence, and you went up to the fence and you put this in to drill that hole and you pulled that trigger all the way. Okay. This is a prime example of not pulling the trigger all the way. You want to, okay, because remember, feeds and speeds. The bigger the drill bit, the harder the material, the slower you go. Okay, so the portable drill doesn't have a set. You don't actually know what RPM you're running at or anything like that. But with a little bit of experience, you can get this thing to go slow. The other neat thing about doing that, about the variable speed trigger here, is that when the head of a screw is about to seat into the material, back off, because it's a lot of torque going into that. Okay. This smaller drill is not a drill; it's an impact driver. It doesn't have as many functions. Okay, except it has a variable speed trigger and a forward and reverse button. This is great for putting in screws. That's why now they started doing it probably around 5 years ago. You can buy these as a set, and you can buy them individually too, but you buy these as a set. So this is what you use to drill your holes or all kinds of stuff. But this is what you're going to use to set fasteners, this impact driver. Often there's like 4, this one doesn't have it, that's unfortunate, but there's 4 different impact forces that you can select. So if you had a small fastener, you could select number 1, and that means that it'll clutch out, just like I showed you on the portable drill. It'll clutch out. The clutch will disengage, and it will stop. It'll stop. Way that they don't, I guess you can call this a chuck. This has this little interchangeable holder, and it's magnetized, and these are the drivers. We just went over this, so this is a number 2 Phillips, and it just drops in here. And when you buy screws, or commonly now the box of screws comes with the Torx driver, or the Robinson driver, the square head, or the Phillips drive. This is an impact driver. Okay. Before we continue, let's briefly discuss force and torque. I'm not going to get into heavy detail about this. That's not what this class is about. But I use those terms, and some might find that I kind of use them interchangeably. And even though I don't, that's why I say some might find that I use them interchangeably. They're very two different things. I'm not going to get into the physics of torque, but torque typically is an instantaneous force. Instantaneous force on something that's rotating. It can be not rotating too, but like I said, I don't want to get into that. When I say instantaneous, it's like that's where impact things start to get confusing, but this is not a physics class, and we're not going to get into it. Force, and I'll go back. Force is something like if I were to apply a load. So if I have, here's my hand, and I push on it, right? It wants to move away, right? I am applying a force to something. So if I take this wrench and I put it on a bolt and I barrel on it, right? There's a certain amount of torque that's happening at an instantaneous moment. But my whole force that I'm pushing in, that's force. I know, confusing. But I just want to touch on that, okay? Impact. Impact, for the SAE guys out there, that's the one. You can calculate force all day long going through suspensions and through your frame, but impact is the one that typically gets us, especially for the Baja car. Like an off-road vehicle, if you imagine an off-road vehicle, it's when it hits a rock, bam, right? That's not necessarily it is force, but it's more of an impact. And impact typically is what breaks stuff. When you have a stuck bolt, you can put all kinds of force on there all day long, man, and that thing doesn't budge. But as soon as you take your wrench and you tap it with a hammer and give it some impact, that's when it starts to free up. It vibrates, it loosens everything up, okay? That is the very basic difference between force, impact, and torque. Okay, so let's move on. All right, change subject. I got this one because it's really small. This is a portable, it's not plugged in, so I don't even need safety glasses, okay? This is a portable saw. Also known as a skill saw. Skill saw is a brand. It is not, I'm trying to fix the extension cord here so it doesn't get in the way all the time. Skill saw is a brand. It's not a type of saw. All right. When we use, these are dangerous, okay? And when we use this, I will hopefully give a demo on this, but the reason why I brought it out, and I have another saw down here too, is because I want to talk about something that's really important with power tools. This goes for every power tool that and I've been thinking about this for years. There typically is only 2 power tools in the world that you start with the material touching the cutter. Okay? So just in case you're confused, the drill bit is in the tip, it's the cutter. The blade here, right? That's the cutter. Okay? You never, ever start a cutting tool with the cutter touching the material. Never, ever, ever. The 2 tools that I can think of that you can do that is when you, is a drill bit, okay, and what's called a random, and I'll show you that, random orbital sander. Okay. That's the round, not the square one, I know, I'll show you. The round palm sander. Okay? And when we talk about sanding, we'll talk detail about that. These are the only two tools that you would ever, and I'm stressing this massively because I'm going to demonstrate right now what happens. You ever start with the cutting tool on the material, okay? The drill, you start with it not in a drill press, only with the portable. The drill press, you do not start with the drill bit touching the material, ever. Never. Never, ever, the drill press. Just this. Obvious, right? If I had my crosshairs here, this is where I wanted to drill. Crosshairs, and I started it here, it'd be a disaster, okay? So you would line this up. No, I'm not going to pull the trigger and drill a hole in the board, okay? Then that would be one exception to the rule. Okay? Why don't we do that? Let's take this Now I have this small piece of wood because it's something I can manage when I'm demonstrating on the board here. It's not plugged in. If I start with the cutting tool against the piece of wood, what's going to happen? Wha-bam! This thing is going to shoot out at me, and it's going to take a gigantic chunk out of my material here. I mean, like huge, just like this. It's gonna chew this all up, and there's gonna be this giant chunk taken out, giant. All right, and it's gonna be all mangled up, and you could get really, really, really hurt. Okay, so what you do is you start with it back. See that there? You know, like an inch back. And you line up your line, you know, okay? And then you pull the trigger. You never start a saw or any power tool for that matter with the cutter touching the material. And let me show you another saw. Okay? So that's a circle saw, portable circle saw. This is a saber saw. Okay? People call them a jigsaw. It's not a jigsaw. What's that? Jigsaw? It's making jigs? This is a saber saw. And if we look really closely, okay, look at the teeth. In what direction they're pointing. Sorry, get this cord out of the way. So I'm falling on my face. All right. So here's the base of that saber saw, and if we look down here, we've got this, and the teeth go like this, okay? And this saw blade reciprocates up and down when you pull the trigger, okay? I don't even like to call it a saber saw, actually. I prefer the term, and this is just me, so this is not like, this isn't accurate, reciprocating saw. Also known as a sawzall. I'm not going to get into that. That's for house stuff. That's known as a reciprocating saw too, or commonly known as a sawzall. But let's go back to the point. If you start this touching the material, like this, what's going to happen? The same thing that happened with the circle saw, but now even more extreme. Now you're looking down because you're looking at your line, right? You're hovering over this thing. You pull the trigger with the saw blade touching the material, and bam! It's going to come up and hit you in the face and knock out your teeth. You're going to get a bloody nose. Who knows what's going to happen? Okay. And it's going to ruin your project. Okay. So I'm a big believer in, of course, safety first. Been doing this all my life. I got all 5 digits, 10 digits. 5 digits, that's funny. But I also am a big, I really want your project to turn out. I want you to not ever get injured, number one, okay? And number two, I want your project to turn out. And then guess what? Number three is the blades dulling, and that is, I'm not concerned with that. Look, I break stuff all the time. Stuff gets dull on me all the time, and stuff just happens. And typically, the students here at school are inexperienced, and they need to learn. A lot of people are concerned mostly about safety first, then the cutting tool, and then your project. Well, number 2 and 3 I have flipped. I want your project to turn out. By doing that, my philosophy is that you're going to learn the right way to use these tools because you want your project to turn out. And you will make mistakes, and that's great. I think you get my point, okay? So that's my philosophy towards that. It's not my money, it's not your money. If you burn out a drill bit because you're getting experience, that's $3 or $4 well spent, as far as I'm concerned. That's on the university. All right. Okay. That's what we're here for. This is, and I grabbed the small one on purpose because it's easier for me to handle during a demonstration, but typically the blade for most standard portable circle saws. Okay, this is a portable circle saw. It's not a skill saw. Or 7 or 6 and a quarter, 7 and a quarter, one of those. That's your typical. This is unplugged, by the way, while I handle it like this. I'm going to demonstrate how to use this safely. These are dangerous. I'm just going to tell you they are dangerous. They are common everywhere, but they are dangerous. All right. The two dangers. I hope I don't need to say this every single time. Safety glasses are required. It's always required. Okay. I hope I don't need to. If I forget, I'm sorry. Okay. To say it, it's a lot to talk about. Okay. This is the guard that moves. This is absolutely a necessity. You must use this guard. If it's like that when you see it, then this is very, very dangerous. People get hurt on these in all kinds of ways, but the two most common types, this is still unplugged, I'm not even going to, I can't even turn it on, okay? Ways is that when they're holding it and they're cutting through it, their hands are in the way or their leg is in the way or something like that. So that's probably the most common. The second one, which I want to demonstrate for you when we're cutting, I'm going to stop cutting and show you, is that as we're cutting the wood, say we're cutting, where it's been cut starts to close in on you, okay? And as it's closing in on you, the longer it is, the more it's going to close in on you. And it starts to grab the blade, okay? And then what starts to happen is it starts to want to kick up on you, okay? And then you're out of control. The technical term for the cut is called kerf. We're going to talk all about that when we analyze saw blades, but I just want to show you how to use this and how to use it safely, okay? If you notice here, still unplugged, if you notice here, the teeth, it's going to be in this motion. You can see that. Why? The reason is because it's going to inherently want to pull the material up onto the rest here, making complete contact. Once again, the tool is doing the work for you. All right. So that's why. If it was going the other direction, it would want to push the material away, and then it would be flopping around, all out of control. All right. So it's real important that the blade is installed properly and going the right direction. This one's small, but there's an adjustment here, and it's right here. There's this thumb screw, and what it does is it moves the rest up and down. Okay, that's one adjustment for different thicknesses of materials, which we'll talk more in detail when we talk about saws. And then there's the other adjustment right here that moves this, that tilts this, like say at a 45-degree angle, so you could cut a 45-degree. I'm not going to do that because this is set at, and I've tested it with a square. It's already set at 0, and I want to keep it that way because that's, on this particular saw, like 100%, I never put it at 30 degrees or 45 degrees. Okay, so I was just going to, before I plug it in, you're going to hear me say this all the time, all right? And I can't stress to you how important it is. As a matter of fact, it's so important and so unsafe that I won't even demonstrate how, what it looks like when you make the mistake. There are only 2 tools in the whole world that you start with the blade touching the material, and that is the cordless, not the drill press, the cordless drill, and the random orbital sander. So that means that I'm going to start cutting with my material, like an inch away, or like an inch away. Okay, it's going to be like an inch away. All right, that makes sense. All right, so now I'm going to plug it in, and I'm going to give you a quick demonstration on how this is done. Okay. So clearly, I'm going to be cutting away from me. I am never going to do anything like this. I'm not going to do something like this where I can go into the table. I'm not going to put my hand here, okay, and do that. If I wanted to cut this like this, I would need to clamp this down to the table, all right? And, okay, but here I'm just going to trim this edge off, okay, and here we go, okay? Notice that if you can see, the blade is not touching the material. What I really want you to pay close attention to is my feed rate. Okay. I'm going to wait for it to stop. Always, and then I can set it down. Okay, I didn't even draw a line or anything. That's not what we're here for. I'm showing you how to use this tool safely. So if I were to have it's going to leave a really yucky edge. You can see my edge
edge is really nice, even on the top, okay? And that's primarily because my feed rate was slow and my blade is sharp. My hands are way out of the way. I'm always moving away from me, and I'm in complete control all the time. If at any point let me demonstrate one more time about how let's say I wanted to trim it long ways, okay? All right, and okay, so I'm gonna trim this long ways. There's absolutely no way that I can hold this safely. So what I'm gonna do is I'm gonna use a clamp. And what I'm gonna see here, move this on the floor. I'm gonna clamp my material to the table. Here. Okay. Hang on. That's just how it is sometimes. Clamp this to the table. Okay. Now it won't move. All right. And I am able now to what's going on here? Something weird. Is that safe? That's not safe. Why isn't that safe? I'm out of balance. Okay? So I'm out of balance, which means that when I reach the end, because I'm out of balance here, and I reach the end and whoa, okay? That could be real bad. All right? So notice too that I just didn't clamp this up and just start, because here I'm fine, right? I thought through to the end. So when I get over here, I'm out of balance. So how am I going to solve this problem? All right. Well, I got an idea. And this is just what it takes, okay? This is what it takes. Did I make the cut because I'm in a hurry or I'm lazy or anything like that? No. As a matter of fact, I'm going to make another error. I'm going to put this here and I'm going to say, okay, I'm going to bring it closer to me. Got this clamped on the table again. All right. That's what I'm still in balance. That's what I'm doing. But the clamp's in the way. Ah, man. Okay, you guys. This is what it's all. This is what it takes. Okay. So now I'm going to move this clamp. Okay. I'm going to figure this out here. What am I going to do? Oh, okay. I got an idea. I'm going to bring this over a little bit more. Turn the clamp around so you can see what I'm doing. Okay? And I'm going to clamp this here. And, that's... Yep. I need another clamp. So I got another clamp. Clamp this down on the other side too. Okay. Now let's see what we got here. Notice my finger isn't on the trigger at all, even though there's this red safety right here. It's still not on. I think I'm pretty good. I'm in balance now. Oh, bad news. All right. So I've got my balance. Everything's clear. The cord. The cord's hanging down. Okay, hang on. Let's get this out of the way. Okay. So now, look at where the cord's going now. it's falling behind me. It's not in front of me anymore. Okay. Okay. All right. So now it looks like no cord, no fingers. Kidding. Most importantly, this is not moving, and I'm not going to be out of balance. The cord's out of the way. I'm going to make my cut. Follow through. Okay. All right. Setup. Setup is the name of the game. All right. Now, I'm going to unplug this immediately here. Unplugged. Out of the way. Let's move on to another type of saw. This is a jigsaw. Okay. That's a slang term that I think has become standardized. It's a reciprocating saw. No, it is not a skill saw, but it is a reciprocating saw. And all right, let's see. The rest pivots 45 degrees, 30 degrees, wherever you want it. I'll be honest with you, I don't think I've ever used a jigsaw with the rest at 45 degrees. There's other methods for cutting. What are these for? They are for cutting. I need my pencil. Say you wanted to cut a circle in something, or you wanted to cut an irregular shape. Can't see that. Or you wanted to cut an irregular shape. All right. All right. How do we do this? The first thing we're going to do, let's use this. First thing we're going to do is we're going to drill a hole so we can get the blade in. That's what they're for. But I also want to, this particular jigsaw has quite a few features to it. For the most part, for this demonstration, oh, by the way, this is unplugged. Okay? I'm not going to so much talk about the features of this saw. It has a lot of features and they are very useful. But what I want to point out mostly is which direction the teeth are going. You see that? The teeth are moving up. And its action, the way that it cuts, it's reciprocating. So it's going to go, all right? So while it's unplugged, if it's designed to be held like this, there's the trigger, okay? Yes, it's a variable trigger too. And your other hand can go here, which means that if I wanted to drill this hole, if I wanted to drill out that circle, do you think, and I want two hands, what do I have to do with the material? I have to clamp it to the table. Absolutely, absolutely a must. All right. We'll cut this circle with this. But what I really want to point out to you is that if I start like this, I mean, you can already see this is a disaster waiting to happen. If I start off with the blade on the material and I pull the trigger, it's unplugged. Remember, what's likely to happen? Shabam! Okay? Boom! Right in the face. So it's absolutely imperative that you do not start the tool with the blade touching the material. Absolutely, like it's so important. Okay, so let's drill this. Let's cut this circle out. All right. So what I'm going to do first is I'm going to go ahead and use the backing support here. I'm going to take my drill, and I noticed that I'm clutched. Remember where I left off because I had the bit in there. Okay. So I'm going to go ahead and put the drill on drill, and I'm going to put it on 2. All right. I'm going to make sure that the bit is in there right and tight, not crooked or anything like that. And pull. I'm going in reverse. Notice how I try it before I try it in air. I cut air before I try it on my material. Okay. Now we're going. Okay. So yeah, I think this is a pretty safe cut. I've got lots of leverage. I've got a backing material. I'm not going to drill into there. My drill's set up. I think I'm pretty good. Oh, let me do that again. When I got through, I didn't let go of the trigger. I kept the trigger pulled while I pulled the drill bit out. Let me do that again. I'm not pulling the trigger all the way. Yeah, I went through. Now I let go. Okay. 2 nice clean holes on the bottom. Remove my scrap. It's unplugged. This, you guys, is not going to work. One-handed like this. This does not work. Okay? Not only is it unsafe, I'm moving that out of the way right now. Not only is it unsafe, your project isn't going to turn out. Okay. So what am I going to do? That's right. I'm going to clamp it. And I'm going to set this up. So of course, as usual, I'm going to run into problems as we go, like I try and do all the time. Okay. That's not going anywhere. Okay. Okay. So now I'm going to plug it in, which means I got to be attentive. Okay. Notice when I picked it up, let me do that on camera. When I picked it up, I didn't pick it up with my finger on the trigger. Okay, I picked it up without my finger on the trigger. So there's no way that something could happen. Okay, and what I'm going to do is I'm going to insert the blade into the hole. All right, making sure that when I pull that trigger, the blade is not going to be touching the wood. All right. Otherwise, if it does, it's gonna shoot up on me. And so we'll see what happens. Hopefully, when I get around, the clamp will be in the way, and I'll have to start over so you can see that. All right. So the cord is clearly out of the way. I have my safety glasses on, obviously. I can see in there. My blade is not touching anything, so I'm cutting air inside that hole. All right. I'm cutting air. I'm going to keep saying it. I'm cutting air when I turn this thing on. All right, when I turn the jigsaw on, not thing. All right, you ready? And I backed off a little bit on the trigger. I don't know. So what I'm going to do is I'm going to pull the trigger all the way, and you're going to hear it, and then because you can't see it, and then you're going to hear it slow down. That? Right about there, that's where I'm going to cut. I'm not on the trigger all the way. Now there is a dial here. Okay, this particular jigsaw is really nice. It has a lot of features, but I purposely set the dial for full speed so you could, because most jigsaws do not have that feature. Okay, most don't. This one does. So I could set the dial on the trigger so when I pull all the way, it doesn't go all the way. The actual mechanical dial that doesn't let the trigger engage all the way, okay? But I purposely set it to full throttle so you could see me throttle the trigger, okay? Right, so here we go. I'm not going to stop this time. Okay, I'm going to do it. Stopped, okay, because my tool ran into my clamp, and I did that on purpose, okay, so you could see, okay, now how am I going to solve this problem? Okay, well, first of all, I'm going to remove the tool from the material, okay, and what I'm going to have to do is readjust my holding strategy, and fortunately, okay, on this one, it's not going to be that difficult to do. I'm just going to reclamp it, get it out of the way. All right, now, like I said, I did this on purpose because I picked it up without my finger on the trigger. Okay, you will be tempted to put the blade back into where you cut. You notice how hard it is to get it in there. I had to kind of push it in there. What's going to happen when I pull the trigger? And I'm going to, most likely at this point, it probably won't hit you in the face, but you could get hurt, okay? But what's going to happen for sure is that it's going to mess up your cut, all right? So what you need to do, all right, is it's going to go a lot faster this time because we're not going to be cutting much, but you need to start over, all right? I'm serious. You need to start over. And so I'm going to do that. I put it back into my original hole, and I'm going to come back around, okay? I'm cutting again. I hit the clamp again. I've got a hole here, so I'm just going to start here. All right. Now I'm in a position where things are awkward. I definitely don't want this to come forward on me, okay? So what I'm going to do is I'm going to start over here, all right? I don't want to come back around. If the blade were to break or something, it's gonna hit me, all right? So you guys, I'm overemphasizing all of this, okay? But I hope I'm making my point very clear. Is that it takes patience, okay? I'm gonna put this in the original hole again, and I'm gonna come back around and meet my cup. Waited for the tool to stop, pull it out, lay it on the table, not the floor. I'll show you what we have here. Okay? If you notice, I have that spot where my original start and was, where that hole was. What I'm going to do is I'm just going to come around here and just really. I'm just going to clean this up real quick, okay? And that's how that's done. I'm actually going to do it on camera right now. Okay. Yeah, that's pretty good. Yeah, that's good. Okay. Set up. Set up. Set up. Set up. Set up. And patience. Understanding the tools. Understanding what you are trying to accomplish and not going into it in a hurry. Not going into it without a plan. Thinking a bit ahead. Of course, priority is thinking ahead so you're safe. Okay? But we'll do more. This is what this class is. So we're gonna keep going and going and going and going, and I'm gonna try and do this as much as I can.